In 1990, Boeing launched a program that would define long-haul aviation for the next 3 decades. They invited 8 major airlines, United, British Airways, Lufthansa, ANA, and Cathay Pacific, directly into the design room. Not for focus groups, not for branding feedback, for actual engineering input. Cathay Pacific's suggestions changed the fuselage width. The result was the Boeing 777. From program launch to first delivery, 5 years. On time, on budget. Over 2,300 aircraft ordered. It killed the 4-engine dominance of the 747 and became the backbone of international aviation. That was Boeing at its peak. In 2013, Boeing launched the 777X, a successor to that same plane. It was supposed to enter service in 2020. Today, in 2026, not a single passenger has flown on a commercial flight. First delivery is now projected for mid-2027, at the earliest, and even that date Boeing's own people won't commit to firmly. To understand the 777X, you first have to understand what happened to Boeing in the years between building the original 777 and launching its successor. In 1997, Boeing merged with McDonnell Douglas. On the surface, Boeing absorbed a competitor. In practice, the opposite happened. McDonnell Douglas executives took over the combined company. Harry Stonecipher, the incoming CEO, later described his tenure this way. "When people say I changed the culture of Boeing, that was the intent, so that it is run like a business rather than a great engineering firm." He reportedly referred to Boeing's engineers as arrogant. The running joke in Seattle was that McDonnell Douglas had bought Boeing with Boeing's money. Boeing's headquarters moved from Seattle, where the planes were designed and built, to Chicago, where the finance teams were. Engineers were gradually replaced by MBAs. Decisions that used to be driven by what was technically right started being filtered through what was financially efficient in the short term. That shift didn't show up immediately. The damage took years to surface. But when it did, it surfaced on every program Boeing tried to run. By 2011, Airbus had repositioned its A350-1000 specifically to challenge Boeing's most profitable aircraft, the 777-300ER. Boeing had 2 options: build a completely new aircraft, which would take a decade and cost tens of billions, or upgrade the 777 with new wings and engines, get it to market faster, and defend the segment. They chose the upgrade path, officially launching the 777X in September 2013. Lufthansa and Emirates signed on as launch customers. At the 2013 Dubai Air Show, Emirates alone placed an order worth $99 billion, 150 aircraft plus 50 options. It was the largest commercial aircraft launch by dollar value in aviation history. Boeing set a target entry into service of 2020. The plan looked clean on paper. Used a proven 777 fuselage, add composite wings adapted from 787 technology, fit the GE9X, the most powerful commercial turbofan engine ever built, introduce folding wing tips, a feature never before used on a commercial airliner, so the massive new wingspan would still fit existing airport gates. 7 years to market, a straightforward upgrade of a proven design. The problems didn't arrive one at a time. They stacked. Boeing built a brand new $1 billion composite wing manufacturing facility in Everett, Washington. The facility was necessary because the 777X's wings were too large to outsource the way the 787's wings had been built in Japan. But building cutting-edge composite structures at this scale, in a new factory with a new workforce, meant a steep learning curve that Boeing hadn't fully priced into the schedule. Then there was FAUB, the Fuselage Automated Upright Build. Boeing's plan was to use robots to automate the riveting process, replacing the manual, labor-intensive assembly that aircraft manufacturing had relied on for decades. It was a bold idea. It was also a failure. The automated systems created defects that workers then had to fix by hand, the very workers the robots were supposed to replace. Boeing abandoned the entire FAUB concept in late 2019, after years of wasted development time and investment. Meanwhile, General Electric discovered durability issues in the GE9X's high-pressure compressor and pulled the engines back for a redesign. The first flight, planned for 2019, slipped into 2020. And in September 2019, during ground pressure testing, a 777X fuselage ruptured at 148% of design load, just 2% short of the required threshold. Boeing reinforced the structure and moved on, but the FAA was watching every step. On December 8, 2020, a 777-9 test aircraft experienced what engineers call an uncommanded pitch event. During a test flight, the nose pitched violently up and down without any pilot input. No warning, no command. The plane moved on its own. This would have been serious at any time, coming less than 2 years after the second 737 MAX crash, an accident directly caused by a flight control system behaving in ways pilots couldn't predict or override. It was catastrophic for the program's relationship with regulators. The FAA responded publicly and forcefully. In a June 2021 letter, the agency told Boeing the 777X was not ready for type inspection authorization, a critical certification milestone. The FAA stated Boeing had failed to provide a complete technical explanation for the pitch event or demonstrate that their proposed fixes would work. Other global regulators, including EASA, launched their own independent evaluations rather than deferring to the FAA as they historically had done. Boeing also redirected engineering resources away from the 777X during this period to fix the still unresolved 737 MAX certification issues. The 777X stalled while engineers worked elsewhere. By July 2024, after years of accumulated delay, the FAA finally granted type inspection authorization for the 777-9. FAA pilots began their own certification flight testing. For a few weeks, progress looked real. Then on August 15, 2024, a test aircraft landed at Kona International Airport in Hawaii after 5.5 hours of flight. During the post-flight inspection, engineers found a fractured thrust link, one of the titanium components that transfers engine thrust to the wing pylon. When Boeing grounded all test aircraft and inspected the rest of the fleet, they found systemic cracks across multiple aircraft. This was not one bad part, it was a design problem. Boeing redesigned the components and developed new inspection procedures. More months gone. Then in January 2026, Boeing and General Electric identified yet another durability issue in the GE9X engine during routine inspections. Boeing has not publicly disclosed the full scope of the problem. The issue remains under investigation. The original 777 took 5 years from launch to first delivery. The 777X has now consumed 13 years and is still counting, without a single commercial delivery. Boeing has spent $32 billion on the 787 Dreamliner program and still has not broken even, needing somewhere between 1,300 and 2,000 sales before the program turns a profit. The 737 MAX groundings cost Boeing $20 billion in direct losses and over $60 billion in indirect costs. Every dollar spent rescuing other programs was a dollar not going to the 777X. And sitting at the center of it all is one airline. Emirates holds approximately 270 777X orders, nearly half of the program's total 619 orders across all customers. Emirates has explicitly threatened to cancel if delays continue. One airline is the difference between this program surviving and collapsing. That is not a customer base, that is a single point of failure. The original 777 succeeded because Boeing brought engineers and airlines into the same room and built exactly what the industry needed. The 777X has spent 13 years struggling because Boeing spent 2 decades building a company that optimized for quarterly earnings over engineering discipline. The 777X is not a bad airplane. The ambition behind it is real. But ambition without the organizational culture to execute it is just expensive. Harry Stonecipher said he changed Boeing from a great engineering firm into a business. The 777X is what that business looks like when it tries to build a great airplane.